Hi, this is Mrs. Cribb. I need you to pull out your Chapter 9 notes and turn to the section on Chapter 9b on Stoichiometry, right here. And it says dun 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 because this is the harder stuff. But as long as you follow things step by step, you'll be fine. First of all, stoichiometry is about the mathematical relationships between the amount of reactants and the products. Okay, and it's very, very similar to a recipe. So let's look right here. We have a recipe for cream cheese bars, and it involves 2 cans of crescent rolls, plus we mix it with, you're going to use 2 cans of crescent rolls and 1 bar, basically, of cream cheese. And then you're also going to need a cup of powdered sugar and a teaspoon of vanilla. You'll use 2 tablespoons of butter, 2 tablespoons of cinnamon, and 2 tablespoons of sugar. And if you follow directions and mix all that together, you create 12 cream cheese bars. So this side over here is the reactants of your equation, and this would be your products. Okay, so we can treat this just like a chemical reaction. Now, what if I don't want 12? What if I want 24 cream cheese bars? I have a lot of people I want to feed. Okay, so instead of 12 cream cheese bars, I need twice as many, because 24 divided by 12 is 2. I need 2 times as many, twice as many. Okay, so that would mean I would need 2 times 2, twice as many cans of crescent rolls, or 4 cans. I would need 2 bars of Philadelphia cream cheese, or just cream cheese. I would need 2 of these, so 2 cups of sugar. I would need 2 of these, because I multiply everything by 2. So 2 tablespoons of vanilla, or 2 teaspoons of vanilla. I need twice as much of this, so that's going to give me 4 tablespoons of butter. Twice as much of this, so I'm going to need 4 tablespoons of cinnamon. And twice as much of this, I'm going to need 4 tablespoons of sugar. Okay? And so if I double everything, I get double the recipe. Right? That's great. So what if I don't want 12? Okay, what if I want only 6? Okay, so I'm going to erase this for a second and pull this up again and use a different number. What if I want 6 bars? Well, 6 bars is half of 12, right? Because 6 divided by 12 is 1/2. In other words, I need half of everything. So instead of 2 cream cheese rolls, I only need 1. So I'm going to divide everything, or multiply everything by 0.5. Or multiply everything by 1/2. Okay? Or divide it by 2. I only need 1/2 of a bar. I need only 1 cup of sugar. Instead of, no, actually I need 1/2 of a cup of sugar, because the original recipe only had 1. So 1 divided by 2, or 1 times 1/2. Instead of 1 of these, 1 teaspoon of vanilla, I only need 1/2 teaspoon of vanilla. Instead of 2 tablespoons of butter, I only need 1 of them. Instead of 2 tablespoons of cinnamon, I only need 1. Instead of 2 tablespoons of sugar, I need 1. And that will give me 6 bars. This one right here gave me 12 bars. I'm sorry, 24 bars when I doubled everything. So all this is a ratio, and it's what you need to do if you want to make a recipe, and you naturally do this. So down here it says, now what if I want 6? 1/2 the products means 1/2 of the reactants. So 6 is half of 12, so I need half of all the reactant pieces. Okay, this is the same thing that happens in chemical equations. The amount that I need might change, and so the amount that I use up will also change. Okay, so let's move on from here. It says, now this means that 2 cans of rolls will give you 12 bars. And that's a ratio, a 2 to 12 ratio. 2 cans will give you 12 bars. And I can write ratios like conversion factors. 2 cans will give you 12 bars, or 12 bars needs 2 cans. That's the ratio, 12 to 2 or 2 to 12. And then you could also do another ratio. 2 cans of rolls needs 1 ounce container of cream cheese, 1 8-ounce container. So that could be a different ratio. 2 cans of rolls in order to use them all up, I need 1 8-ounce of cream cheese. Or I could write the ratio differently. I could put 1 8-ounce of cream cheese over 2 cans of rolls, using the same recipe right up here at the top. See, there's 2 cans and 1. So 2 to 1, or what was the first one I did? 2 to 12. I can do a ratio of anything. So let's do some more ratios. What about the cinnamon to vanilla? Okay, this would be 2 tablespoons of cinnamon to 1 teaspoon of vanilla. Right? That's the ratio. So that's a 1 ratio. 2 of these requires 1 of those. It's a 2 to 1 ratio or 1 to 2 ratio. I could also say 1 teaspoon of vanilla has to have 2 tablespoons of cinnamon. Okay? So 2 ratios, either one. And then the ratios are used in the math just like conversion factors. Okay? So I can do any kind of ratio that I might need. So now let's move on and see how those ratios work with chemistry. In chemistry, again, we have the reactant side and the product side, right? And there's a ratio again. And this time what we're going to do is the numbers, I'm going to put a 1 right here because that means 1, this 1 in front tells you the number of moles in the recipe, in the reaction. So there's 1 mole of phosphorus reacts with 5 moles of oxygen, and when they react, they form 2 moles of diphosphorus pentoxide. This is the ratio. Okay, just like up here, 2 cans of crescent rolls plus 1 cream cheese, 1 cup of sugar. This has got a lot more reactants. 1 teaspoon rather, 2 tablespoons of butter, 2 tablespoons of vanilla, 2 tablespoons of sugar. Those are all the reactants. Gives you 12 bars. That's the reactant side, is all of these things reacting together to produce the products. Okay, so here, this reactant side, all those things work together to produce these products. Now, in order to go from one side of the equation to the other, we have to use a mole bridge, but we have to be able to understand those ratios. So let's do a couple of ratios now with this thing. What's the ratio of phosphorus to P2O5 on the other side? Well, 1 mole of phosphorus, it's going to work and it's going to give you 2 moles of diphosphorus pentoxide. So the ratio is 1 to 2. Or I'd write it like this: 1 mole of phosphorus for every 2 moles of diphosphorus pentoxide. Or, because ratios can be used in either direction depending on which one needs to be on top, which one need to cancel, I could also say I get 2 moles of diphosphorus pentoxide when I use up 1 mole of phosphorus. So this is a 1 to 2 ratio. These coefficients in front, right here, coefficients, right here, they all represent the number of moles that you're using in your equation. So that's one more. Okay, let's try a different one. What about the ratio between oxygen and phosphorus? All right, so 1 mole of phosphorus has to react with 5 moles of oxygen because of those right there, the ratios, the coefficients in the front. Or I could say 5 moles of oxygen have to react with 1 mole of phosphorus. That's a different ratio. I can also do a ratio, I'm going to use a different color now, between oxygen and diphosphorus pentoxide. So you can pick any 2, it does not matter what 2, just any 2 on the equation. You can set up some ratios. So I'm going to set these ratios up on top. Notice that there are 5 moles of oxygen will create 2 moles of diphosphorus pentoxide. Or I could say 2 moles of diphosphorus pentoxide are created by 5 moles of oxygen. And it just depends on which part of it you need to cancel out. These are the ratios you're going to use. And these ratios create something called the coefficient ratio bridge. And that, if I could zoom in on this over here, you might see that it says coefficient. Maybe I'll do that for just a second. There it is, the coefficient ratio bridge. Right there, coefficients. Now, the coefficients come from the mole ratios. The mole ratios that we've been doing right here. These are the mole ratios. That's what they are, mole ratios. I have another picture in the bottom that has little moles walking back and forth. Because remember, this is a bridge, and on a bridge you can go both directions. You can go for right or left on a bridge. So depending on what you need to do in reaction, you're going to use this mole ratio. But it's the only thing that will get you from one side to the other side. Okay? So now let's look at this question. If 25 moles of diphosphorus pentoxide, so when I do these equations or these questions, I always take the given information and I put it underneath the equation. Now, I will tell you this right now. In order for this to work, you must have a balanced equation. So if your equation is not balanced, you're going to have to stop and balance it first. And so, yes, you will be balancing equations again in this chapter. And you'll also be turning words into equations. And so there's going to be a lot of review from previous chapters. But you have to have a balanced equation, otherwise this won't work at all. So we start off with 25 moles of diphosphorus pentoxide. So you look down here, you said there, di is 2, pentoxide. So diphosphorus pentoxide is this first molecule. You'll say, look, there's not 25 moles there. The recipe only calls for 1 mole. That's true, but I'm going to use more than that because I'm going to create more than that. I'm going to have 25 moles. So I write the amount that I'm given underneath. Now let's go back and look at our recipe up here. See, when I had this recipe, I only had 2 cans of crescent rolls to make 12 bars. But when I wanted 24 bars, this is the basic recipe. When I wanted 24 bars, I needed 4 cans. Okay? So I had more than the basic recipe. And so what I'm saying is if I have 4 cans, I can end up with 24 bars. So down here, the basic recipe calls for only 1 mole of diphosphorus pentoxide, but I'm going to use 25. So obviously I can make more stuff. So it reacts with water. Now when it just says with water, that means you have more than you need. And we'll understand that a little bit more. That means water, you're going to have all the water that you need, so don't worry about that. To form phosphoric acid, which is one of those acids you're supposed to have memorized, which is this, H3PO4. Okay, how many moles of water are required? Okay, so I don't need, so I don't have more than I need of water in this question because it's actually asking me how many moles. All right, so always read the whole question. Sorry. So how many moles of water? So I always put a question mark underneath what it's asking. It's asking for how many moles of this thing right here. So I have 25 moles of diphosphorus pentoxide and I want to figure out how many moles of water I need. Now you might be able to do this pretty quickly. You can see that the basic recipe calls for 1 mole. I have 25, so that's 25 times more. So 3 moles of water are needed, so I need 25 times more of that of water. But we're going to use those ratios. So 25 moles of diphosphorus pentoxide is what I have. So how many moles of water do I need? Well, I know that for every 1 mole, this is the ratio right here, the ratio bridge. For every 1 mole, I need to use 3 moles of water. So for every 1 mole of diphosphorus pentoxide, I need to use 3 moles of water. This is where I get it from, right here. Every 1 mole of diphosphorus pentoxide, I need to use 3 moles of water. I put the moles of diphosphorus pentoxide on the bottom because the question is how many moles of water. That means it has to be on the top. I have to cancel this stuff up here. Moles of diphosphorus pentoxide, moles of diphosphorus pentoxide. Now, 25 times 3 is 75 moles of water. In other words, if I'm going to have 25 moles of diphosphorus pentoxide, I need 75 moles of water to use it all up to create the phosphoric acid. Okay, that's using the mole ratio bridge. And you'll have a lot of questions like that. All right, the next portion is mass to mole conversions. And notice this right here is the ratio bridge that these little guys are walking across. And the moles can walk in this direction, or the moles can walk in this direction across the bridge, the ratio bridge. So let's do this next question. How many moles of phosphoric acid can be formed from 3,550 grams of diphosphorus pentoxide? Now, it's using the same equation, so I'm going to write the equation down again just so I don't have to flip up and down. Here's the same balanced equation. Okay? And it's going to create 2 moles of phosphoric acid. All right, now, how many moles? Here's the question. How many moles of phosphoric acid? I want to know how many moles of this can be formed. See, that helps you know that it's on the product side. Okay? From 3,550 grams of diphosphorus pentoxide. So I have diphosphorus pentoxide, 3,550 grams of it. Now, what did I say about the bridge, the moles? It's a mole bridge. We have only moles can walk across the bridge. Grams can't walk. They don't have legs. Okay? Only moles can walk across the bridge. So we have to go from moles of one thing to moles of the other thing. So we don't have moles right now. Diphosphorus pentoxide is in grams. See, up here we used moles. We used the mole bridge, saying moles of this to moles of that, and we used a ratio. And the things that we used there, we did the ratio to get from one to the other. That was this right here, the mole ratio. That's the bridge. Okay. So I've got to be able to do moles to moles. So what I need to do then is, since this is mass in grams, the first thing I got to do is turn my mass into moles using the molar mass. So I need to know the molar mass of diphosphorus pentoxide. I need to calculate that. Okay, now I've done that for you. I've calculated the molar mass of diphosphorus pentoxide. Remember, there are 2 phosphorus atoms and 5 oxygen atoms. I multiply them times the molar masses I get off the periodic table. And then 2 times 30.97 is 61.94. 5 times 16 is 80. Add these together so that the molar mass of diphosphorus pentoxide is 141.94 grams per mole. I have to know the molar mass to change the grams into moles. So now I take you always take the information you start with, 3,550 grams of diphosphorus pentoxide, and I am absolutely requiring you write the atoms in, the molecule in. So I have to turn it into moles first. So 1 mole of that stuff is 141.94 grams, and then we do the canceling. And we end up knowing how many moles that we have. And I'm going to go ahead and break it down into pieces this time, and then I'm going to do it in one full step. All right, I calculated it out for you. It's 25.01057 moles. That's way more significant figures than I needed. And if you were just stopping here and you did sig figs, I would need 3 sig figs, because this number has 3 sig figs. 1, 2, 3. So I'd need 1, 2, 3. So it'd be 25.0 moles. Okay, and that would be the moles of diphosphorus pentoxide. Now I use the mole ratio, or the mole bridge, okay, to get from one molecule type to the other molecule type. And the ratio is there are 2 moles of H3PO4, and since that's the thing I'm after, it has to go on the top. Okay, it's going on the top. 2 moles of H3PO4. I create 2 of those for every 1 mole, 1 right there, of diphosphorus pentoxide. All right, remember that's the ratio. It's a 2-to-1 ratio in this case. And this goes on top because it's my question, and the question needs to be not eliminated. Now I can cancel out moles of diphosphorus pentoxide, and I can figure out how many moles of H3PO4 would be created. So 25 times 2 is 50.0 moles of H3PO4, and that would be your final answer, okay, using the mole ratio bridge. All right, let's do one more. Let me write it out. We have 2,401 grams of diphosphorus pentoxide, and I want to know how many moles of water are required. So let me write out the equation. Now you can see the equation. All right. Remember the coefficients in front. This is up 1, even though it's not there. These coefficients in front all represent moles. Every one of these are moles. How many moles in the recipe? Okay. So the question is, how many moles of water are required? So question mark here. How many moles of water are required if I have 2,401 grams of diphosphorus pentoxide? So 2,401 grams of this stuff. Okay, if I have this much, how much water do I need? So this again is going from the mass. We got to turn it into moles using the molar mass. And then I got to use the ratio bridge to get to the new moles. Right here. This is the mole ratio to get to the new thing. So we take the mass of diphosphorus pentoxide, 2,401 grams. We turn it into how many moles that is equal to. And I've already calculated the molar mass, and it's 141.94 grams, just like it was on the top. The grams cancel out, and now I have moles, and this is diphosphorus pentoxide. I've got to remember to write the molecule down. Because now I've got moles of diphosphorus pentoxide. Now that I have moles of diphosphorus pentoxide, I know how many. I can use the moles of water ratio to get to the actual amount of moles of water. I can use the ratio between the two. Notice there are 3 moles of water required for every 1 mole of diphosphorus pentoxide. All right, cancel the 1 mole of diphosphorus pentoxide with this one. Now we just take 2,401, we divide it by 141.94, and we multiply it by 3, and we'll get our final answer. The answer is 50.75 moles of water. When I do this multiplication, 2,401 divided by 141.94 times 3. Then I have to account for significant figures. Sig figs come from the beginning value. Sig figs will come from this because that's the measured value. Okay? These things here, this is like a definition. And so we don't use sig figs for the definition, and we don't use sig figs for ratios because those are definite numbers, those exact numbers. So sig figs, this sig fig answer has to match the sig figs at the beginning number. Okay, now we'll go over more of these. You have plenty more chances to work on these, but hopefully this will get us started on stoichiometry.